This video is about systems of equations word problems. Now, in order to not make the video too long, I'm just going to write down the equations that give you the system. I'm not actually going to solve them algebraically. Typically in class, what I'll have you do in word problems is write down the system and then solve it in the calculator, because the real purpose is to interpret the word problem correctly. So if you want to know how to solve a system of equations in the calculator, go to my calculator playlist and there's a video about how to do that. So for this word problem, what you probably want to do is pause the video so that you can read it and see what it is we're talking about. So when analyzing a word problem, one of the first things you want to do is define what your variables are. And a good trick is to focus on the question being asked. Well, we want to find the cost of one roll of these various types of paper. So the problem really told us what the variables were. So I'm going to let x be the cost of a plain roll, and then we'll let y be the cost of a holiday roll. So y is going to be the cost of holiday roll. So now we need to write down two equations that relate these variables. Well, in this problem, and lots of problems like this, you'll have two different situations involving these variables. So in this problem, we have Paul, and his situation is going to give us an equation, and then we have Kali, and her situation is going to give us an equation. So for Paul, he sold 5 rolls of plain paper and 4 rolls of holiday paper. So these numbers, the 5 and the 4, we're talking about how many rolls he sold. Whereas we're also given that he made $98. So realize 5 and 4 is not talking about dollars, but his situation is. So if we put this together, in order to talk about dollars, he sold 5 rolls for X dollars each, and he sold 4 rolls for Y dollars each. So now we are talking about dollars, and the total is 98. We have the same thing for Kali. 2 rolls for X dollars each, 6 rolls for Y dollars each, and she made $114. This must be some really nice paper. Again, I'm not going to solve this equation to make the video a little bit shorter, because in class we're going to be solving these in the calculator anyway. So you would go to the calculator, find the command for solving a system, type these two equations, and you're done. So the hard part is just writing them down by interpreting the word problem correctly. Okay, let's do another example. This one is a little bit trickier. So we have a boat that traveled downstream and back. So I'll use my amazing artistic skills to draw a river. So there we go. There's a river. And we'll say the river is flowing left to right on my screen. So in the river, we have a boat. So there we go. Wonderful. Wonderful boat. And the boat's going to go downstream, and then it's going to turn around and come back. And in this problem, we want to know the speed of the boat, and there's an important clarification: the speed of the boat in still water. So let's let x be the speed in still water, and let's let y be the speed of the current. Now, we've actually seen some problems like this early on in the year before we got to systems of equations, and the idea is that when the boat is going downstream, so when the boat is going left to right in my diagram, the speed is going to be x plus y, because the current is speeding up the boat. However, upstream, the speed is going to be x minus y, because the current is slowing down the boat. And that's really the key. So In order to write the equations down, we're going to use our old friend, distance equals speed multiplied by time. So distance equals speed multiplied by time. All we have to do is put this in our particular context with our variable names. So the distance is 144 miles, that's given in the problem. And let's say we're going downstream. Well, the trip downstream took 6 hours, and the speed we saw was x plus y. So the speed is x plus y, and we're multiplied by 6, because that's the time. Coming upstream, the distance is the same. It's like a round trip, but the speed is x minus y, and the time is 9, which makes sense since we're going slower, the time should be a bigger number. So here's the two equations for our system. Go to your calculator, solve the system. We could solve it by hand, but again, the purpose of these questions is really to interpret the word problem properly. All right, we have one more example to do. And this is more of a number game than anything else. So we have that the sum of a two-digit number is 11. Or sorry, the sum of the digits in a two-digit number is 11. And when we reverse the digits, we decrease the number by 9. So, just with some number sense, you could figure this problem out by thinking about a variety of two-digit numbers. But I do want you to solve this algebraically, or to write down two equations. Because this is an interesting little question, and it shows you the relationship between numbers and algebra. So what we're doing here, we have a two-digit number, xy. The reason I use quotes, normally when you have xy next to each other, it means you're multiplying. But that's not what I mean here. I mean literally you have the digit x followed by the digit y. And in this problem, you're reversing the digits, so you'd have the digit y followed by the digit x. So for example, now this is not the answer to the question, but just to make sure we're on the same page, if you had the number 41 and you reverse the digits, you'd have the number 14. So that's what we're talking about here. Now, before we worry about writing down any equations, we do have this piece of information. When you reverse the digits, you decrease the number by 9. So that means with our original number and the reversed number, one of them is bigger and one of them is smaller. In this case, we know when you reverse the digits, you decrease the number by 9. So the reversed number is smaller, or if you prefer, the original number is the bigger of the two. All right, so what about equations that we can write down for this situation? Well, one of the equations is simple. We know that the sum of the digits is 11. So we know x plus y equals 11. That's the two digits, and the sum is 11. But what about another equation? Well, what we're going to do is use the concept of place value. Since x came first, followed by y, x is in the tens place, and y is in the ones place. So you may remember doing this in elementary school, of course not with algebra, but what this means is, since x is in the tens place, to write the value of that number, we'd have 10 multiplied by x plus 1 multiplied by y. So 10x plus y is the value of this two-digit number. Now, I'm going to write something down that's incorrect, and then we're going to fix it. The value of the reversed number is 10y plus x. So what I have written is obviously wrong. I'm saying that these two numbers are equal to each other, which they're not. The original number is bigger than the smaller number. So since my equation is, well, obviously incorrect, let's fix it. When you reverse the digits, you decrease the number by 9. So the difference between the value of the original number and the value of the reverse number, the difference is 9. And since the reverse number is smaller, I know that the right-hand side is smaller by 9. So to make up that difference, I'm going to add 9. And now this equation is true. 10x plus y equals 10y plus x plus 9. And so we have our system of equations. That is, we have two equations with two variables. Solve this. You could solve it by hand if you wanted to. You can solve it in the calculator. But that's how you deal with digit reversal problems. Anyway, that's a few examples of systems of equations, word problems. Hope that helped.